Okay, we'll begin with a second example now of using partial fractions. Again, note that the derivative of the denominator is 3x squared minus 2x minus 6. This numerator is not a multiple of that. So even though this denominator has an exponent of 1, it is not a logarithm in its present state. We begin by factoring the denominator. In this case, that means first removing the common factor of x. Following that, we factor the trinomial. We want a product of -6 and a sum of -1. That means the numbers are -3 and +2. And now we have our 3 unique linear factors. It means the original integral can be written as the sum of 3 different integrals. In our denominators here will now be x, x minus 3, and x plus 2. Each numerator will have a single letter A, B, and C. All we have to do is figure out their values. To do this, we first picture actually adding these 3 fractions together. Of course, the common denominator would be required. Here we have a over x. If we move to the common denominator, a, of course, will have to be multiplied by x minus 3 and x plus 2. Before going on to add b, which has to be multiplied by the x and the x plus 2. Finally, c has the x plus 2 under it currently, but is missing the other 2 factors. So it needs to be multiplied by x and x minus 3. So the equation we use to determine A, B, and C will look like this. We take our original numerator and we set it equal to this numerator. Perfect. Now what we do is we look for the roots that we may use. The roots, of course, are the values that will make these terms equal to 0. So they are 0, +3, and -2. So we substitute those now one at a time. Let's start by substituting x is 0. If we substitute that on the left side, we will have -12. Substitution of x is 0 on the right side will give us a times -3 times +2, from which -12 is -6a, and after dividing, a is 2. The next root is x is 3. So we'll substitute that now. Now you have to substitute 3 in the left side. So 4 times 3 squared plus 7 times 3 minus 12, which is 45. Substituting 3 on the right side will only give us one non-zero term here. Of course, the 3 here gives me a 0. The 3 here gives me a 0. So the only non-zero term will be here, b, times 3 times 3 plus 2, or 5, from which 45 is 15b and b is 3. 45 divided by 15. The last root, remember, is -2. Be careful when you substitute -2 here. Remember, you have to bracket it. 4 times -2 all squared plus 7 times -2 minus 12 gives you -10. On the right side, -2 here gives me a 0. -2 here gives me a 0. The non-zero term is at the end. C multiplied by -2 and multiplied by -2 minus 3, or -5. -10 is then 10c. This means c is -1. Now we have these values. They will form our numerators. So we go back up here and substitute those values. So we will have 2 over x and 3 over x minus 3, and finally -1 over x plus 2. Once integrated, these will all be natural logarithms. Specifically, 2 ln x plus 3 ln x minus 3 minus 1 times the ln of x plus 2. Constant of integration here. Now, in order to combine these logarithms into a single logarithm, we will use first this property. So all of these coefficients, well, this one here, 2, and this one here, 3, will become the exponents like this. The ln of x squared plus the ln of x minus 3 all cubed. Following that, we'll use the previous two properties. The sum of a logarithm gives you a product in the argument. The difference of two logarithms gives you a quotient in the argument. So if I combine into a single logarithm, I will have x squared multiplied by x minus 3 all cubed in the numerator. The addition becomes a quotient. This one, preceded by the negative sign, means that we will have a denominator here of x plus 2. So that's how to combine the 3 logarithms into a single logarithm. You did learn those properties, by the way. It would have been Math 1231. Okay, so I guess that was about a year ago for your class. Okay, great. So that was example 2. Remember, first, fully factor the denominator. Check your factored version before continuing. Make sure it's perfect by using multiplication. In this step here, we move to a common denominator. We use the 3 roots one at a time to figure out values for a, b, and c respectively. And then for this case only, the case of unique linear factors, each of these fractions can then be integrated. They will all be natural logarithms. Okay, we will do one more example together in a moment.